afternoon, pre-calculus students. So welcome back to Mr. Chen's channel. So today I would like to talk about one of the sections in chapter 9. This one's supposed to be 9.8, partial fractions from James Stewart. And then partial fractions type of problem. So we do have 1, 2, 3, 4, 5, 6. So 6 different types of structure. So let's talk about the first type. So it's called the linear factor. So basically, partial fraction, that means we want to decompose the rational expression with two or multiple rational expression. Okay, so the one with the linear factor, as you can see that the denominator, anytime that it's given with the polynomial, you always want to factor it. If this one is considered like a different factor, the linear factor with the denominator, you can always separate it out into a over, this one is x minus 2. And then the other one, so b over the second factor, x plus 3. So the linear factors, so that's pretty easy to deal with. And what happens once you deal with that case 2, the repeated linear factor? So the repeated linear factor, so we do have 5 over the quantity of x minus 1, and then x plus 2 quantity to the power of 3. So for the first factor, it's just a over x minus 1, because that's just the linear binomial. On top of that, it's just a constant. And then for the second factor, we do have x plus 2. But anytime that you start off with x plus 2, we need to start it off with the linear, and then the quadratic, and then the cubic of the same linear factor. So if that's a linear factor originally, so it's just b over x plus 2, and then raised up to the power of 2. So d over x plus 2 quantity squared, and then plus e over x plus 2 quantity to the power of 3. And for those you might be wondering the constant, how come I'm not using c here? Well, because c always representing the constant. So we don't want to confuse that. So just use any other letter. As you can see that if that's a linear factor, it's always considered a binomial. And then the numerator, it's always considered one term less. Okay, so the numerator, it's always considered one term less compared to the denominator. So this one is just a constant. That means the denominator, it's a binomial. Linear binomial. Okay, so what about once we deal with the quadratic factor? So the first one here is still considered linear, so that's why it's being written as a over x minus 1. And then for the second factor, this one is considered a quadratic. So you might be wondering on top of that, how can we put in the linear binomial? But this one is only the binomial. But don't forget, the quadratic standard form is always written as ax squared plus bx plus c. So you might be wondering the x term is missing. So this one basically is like x squared plus 0x plus 1. So again, back to the fact here, the numerator, it's always considered one term less compared to the denominator. So besides it's 1 power less, 1 degree less, but also it's considered one term less. Okay, so degree. So this one is always less in the numerator compared to the denominator. So it's always 1 degree less. Okay, so now what about case 4, repeated quadratic factor? So once you factor this out, so the first one, that's just a monomial linear factor, so it's a over x. And then for this one, x squared plus 4, started off with the quadratic. So on top of that, it's bx plus d. So a, b, and d, e, f, those are constant, arbitrary constant. And then what about the second one? So x squared plus 4, quantity square. So on top of that, ex plus f. And then finally, the third factor, it's a different quadratic factor, so we put in gx plus h. Okay, like that. So again, the way to solve for a, b, d, e, f, g, and h, so we need to set up the comparison of the system equation. So we'll be able to find out a, b, d, e, f, g, and h. So we'll get to that, some of the example like this later. So for case 5, so that would be a long division. So anytime that I see that the degree in the numerator, it's equal or greater than the degree of the denominator. So first thing that you want to do, you want to perform the long division. So once you get a long division, you'll get the quotient. and also you get a remainder. So rewrite it, quotient plus the remainder over divisor. So going back to what we did in chapter 3, pre-calc, so long division. So this one is being written as 1. And then for this rational expression, we want to decompose it with two different rational expressions. So factor the denominator, we got x minus 5, x minus 1. So linear factor, so a over x minus 5, b over x minus 1. So just like going back to what we have in case 1, linear factor. And then what about the special cases? Similar. So this one's just combine it with the factor of quadratic, linear. So it started with the quadratic, so this one's supposed to be a trinomial. Okay, so some people prefer to do it this way, ax plus b first, or you can just set it up as monomial and then a quadratic factor, so the repeating linear factor, so a over x plus b over x squared, and then for that x plus 2, another linear factor, excuse me, so you want to put it into c over x plus 2. Or you can do it this way, so you can just convert that as a quadratic factor. So ax plus b, just put that on the top. And then for the linear factor, so just put in c over x plus 2. Eventually, for a, b, and c, you'll end up with the exact same result. So now, let's do some example here. So for number 8, decompose each fraction. Again, the word decomposing, that means you want to separate the expression, the rational expression, with two or multiple rational expression. Okay, so started with a right here, so let me put it out. 2x minus 1 over x squared minus 5x plus 6. So first thing that you want to do, you want to factor the denominator. Okay, so factor, you can just simply do it with the smiley face, cross method, doesn't matter, or you can simply do it mentally. So x minus 3, x minus 2. So on top of that is 2x minus 1. So this one is basically just being separated into what? A over x minus 3 plus b over x minus 2. So that just consider case 1. Well, because that it's a non-repeating linear factor. So a, constant over the linear binomial. B, another constant over another linear binomial. And now for those students might be wondering, how do I solve for a and b? The way to solve for a and b. So again, this one, we want to convert this one back to the least common denominator form. So multiply the top and the bottom by x minus 2. So let me use different color right here. X minus 2, x minus 2. And then right here, multiply the top and the bottom by x minus 3. So now, there's no need to worry about the denominator now. It's just about the matter of fact, the numerator. So basically what this one is showing, 2x minus 1. So that equals ax minus 2a plus bx minus 3b. So basically this one, we just want to combine that, the variable. So the one involved with the variable. So you want to convert that as ax plus bx. So this one you want to compare that with 2x. So basically this one is saying that a plus b, the quantity of a plus b times x, so that equals 2x. So in other words, 2, what is that equal to? A plus b. So we just set up one linear equation. And now what about the other equation here? See the constant? So compare with the term of the constant. So that would be negative 1 equals negative 2a minus 3b. Okay, so basically right here we just set up the system equation. So a plus b, so equals 2, and then negative 2a minus 3b equals negative 1. And then from here we can solve for a and b. So you can use any kind of method you want to solve for a and b. Reduced row echelon, linear combination, substitution, Cramer's rule, or the inverse notation converted to the augmented matrix. But just use the basic way, combination. So basically this one multiply the first equation by 2. So we got 2a plus 2b, so that equals 4. Combine it with the second equation. So 2a, negative 2a got cancelled. So 2b plus negative 3b, so negative b. And then 4 plus negative 1, then that would be considered negative 3, positive 3. So that means b equals negative 3. So solve for b, so we can solve for a. So plugging a number back here. So 2 equals a minus 3. So that means a equals 5. So that means this one can be written as a over x minus 3, so 5 over x minus 3, plus b over x minus 2, so negative 3 over x minus 2. Just like that, decomposing fraction. Okay, so now what about for b? So for b, this one's getting a little bit complicated. So again, we just need to find out which case that belongs to. Whether that's case 1, non-repeating linear factor, or case 2, repeating linear factor, things like that. Okay, so for b, so the top part right there, that's a trinomial. But again, it's all about the key point, the denominator. So again, first thing that you want to do, you want to factor. Just factor the denominator. So this one, take out the greatest common factor. So we do have x. So we got x squared plus 4x plus 4. Numerator, just rewrite it. And then what else can we do? Keep factoring it. So x, carry that over. And then we do have x plus 2 quantity squared. So it looks like this one we do have a repeating linear factor. So again, the way to set it up, so follow through that case too. So start it off with the linear factor, so a over x, and then the next one, so b over x plus 2. Started with the linear power first, and then raise up to the second power, x plus 2 quantity square, then that'll be c. So basically here we need to find out the value of a, b, and c. Again, convert the following, set up here, to the least common denominator form. Okay, so convert it to the least common denominator form. So what we did here, this one's step 2, the setup. And then step 3, LCM or LCD. So a over x. So in order to get that to the same denominator, we need to multiply by x plus 2 quantity squared, top and the bottom. Okay, you know what, let me just rewrite all this down here first, so we can figure out things that's missing. So here, multiply by x plus 2 quantity square, top and the bottom. And then over here, not only we need to multiply by x plus 2, but also we need to multiply by x. Okay, and then this one just need x. So again, it's all about the comparison of all the numerators, the sum of all the numerators, and then the original numerator. So this one expanded out. So what we got here, step 3, step 4, expand. So here's what we got. So it's x squared plus 4x plus 4. And then the other one is just b times x squared plus 2x. And then this one's plus cx. So we want to compare this one with the original numerator. So the original numerator, which is what, 3x squared plus 11x plus 4. And now step 5, that becomes very critical. It's all about the comparison with grouping. So it started off with the one with the quadratic power. So the quadratic power, x squared, so we do have a, b, because once you distribute, it's ax squared, bx squared. And then this one basically is showing that a plus b, okay, let's put it this way. So let's say that if you multiplied it out, or distribute, so we do have ax squared plus bx squared, so that equals 3x squared. Okay, so compare those terms. So basically what this one is showing that a plus b equals 3. And what about the linear term with just one x? So we got a times 4x or 4ax, and then what else? 2bx. Okay, so this one, you want to compare that with 11x. So what this one's showing, 4ax plus 2bx. So again, after you distribute that a and b, so that is the same as 11x. The linear power. So basically this one is saying that 4a plus 2b equals 11. So we just create the system equation here. And then what about the constant? So the constant also, we can create the other equation. Constant, x to the power of 0. So 4a, constant with the constant. So this one, there's no more constant. But plus, well, this one, wait a minute. So 4ax plus 2bx. Forgot one thing here for the previous one. Plus cx. Okay, plus cx, because that's 3 variable. Then that'll be 11x. So 4a plus 2b plus c, so that equals 11. So let me fix that, the second equation. Because this one we do have 3 different constant. So that equals 11. And then the constant terms, so just for 4a. Okay, so there's no more constant along with that 4a, so that means 4a equals 4. So 4a equals 4. So that means a equals 1. Well, if a equals 1, so we can solve for the first equation. Back to the first equation. So that means b, what is that equal to? So 3 minus 1, then that'll be 2. And once we got a, b, so we can solve for c. So 4 times 1, back to the second equation, plus 2b. 2 times 2 plus c equals 11. So 8 plus c equals 11. So that means c equals 3. So a, b, and c, 1, 2, 3. So 1 over x plus 2 over x plus 2, and then plus 3 over x plus 2 quantity square for this rational expression, decomposing. Okay, so gotta be very careful with the step that I need to follow through, so we'll be able to find out all those arbitrary constants. And now going back to the template, let's see what else that we have. So the next one, this one's a little bit lengthy, but I'll just show you the setup. The way to decompose the fractions, the rational expression. Okay, so let's check this out. So back to this page. Okay, so once again, same as what we've been going through. First thing that you want to do, you want to factor the denominator. So compare and contrast, take out the greatest common factor first, as usual. Okay, so x squared. So we got x to the power of 4 plus 2x squared, and then plus 1. And then on top of that, this one no need to worry about, just bring them down. Because eventually, once you expand it, you want to compare that, the coefficient, along with the power. Okay, so this one looks like we do have a quadratic factor. And also for the other one, this one can factor, so it's x squared plus 1 quantity squared. So it's a repeating quadratic factor. So one thing at a time. Okay, so let's try to do one thing at a time. So this one, I'll just rewrite it. Ditto, same as the previous one. Okay, so now we need to set up here, so that's what I promised to show you. So started off with the linear factor. So let's say this one you can do it either way. You can make it as a over x plus b over x squared. Or you can simply just put in that a x plus b all over x squared. So it depends on which way that you prefer. Some people like to use that as a quadratic. Some people like to use that as a monomial, linear, and the repeated linear factor. Okay, so either way, but so let's try to follow with the special case, the first way. And then the other one, quadratic factor. So we need that x squared plus 1. So on top of that, this one will be ex plus f. As you can see that it's a quadratic. Well, the original form, it's like ax squared plus bx plus c. So that's why on top of that, it's always considered 1 degree less, and also is considered 1 term less. And then repeating quadratic factor, so x squared plus 1 quantity square. So let's say that on top of that, gx plus I. Okay, use any kind of alphabetical letter. And then from there, you want to solve for A, B, E, F, G, and I. Again, you don't want to use letter C because letter C, that just represents a regular constant. Like that. So again, this one that involved with the special case. So like what we did for case 6. Okay, so back to the template. So the last one for D. For those you might be wondering, how do I set up the structure for this one? Okay, let's take a look at that for this one here. So degree on the top is greater than the degree down the bottom. So that means we need to perform the long division first. So before we factor anything out, let's do the long division. Okay, so dividend x to the power 4 minus 2x squared. Well, the thing is that there's a missing term here, so let's fill in the gap here. So 0x to the power of 3 minus 2x squared plus 4x plus 1. It's always from the greatest power to the least. And then divisor, x cubed minus x squared minus x plus 1. So in order to cancel out that x to the power 4, we need that x right here. So x to the power 4, x times negative x squared, then that'll be negative x cubed, x times negative x, minus x squared, x times 1, then that'll be 1x. Got to be very careful. You don't want to mess up with any sign change. So once we subtract, so this one got canceled, subtract, this one turns out to be positive, x to the power 3, subtract, so this one turns out to be negative, x squared, and then 4x minus x, which is 3x, and then plus 1. Okay, so plus 1, so one more term that we need to bring down here, so we just need 1 this time. So 1 times x cubed, x, negative x squared times 1, negative x squared, negative x times 1, negative x, 1 times 1, which is 1. So basically, a lot of terms got cancelled here. So 3x minus x, 3x minus negative x, so 4x. So this one, just rewrite it. So what we got here is x plus 1, and then plus 4x all over the same divisor, x cubed minus x squared minus x plus 1. And now for this one, the remainder over the divisor, so we need to decompose that rational expression. So this one, follow through what we just did earlier, factor by grouping. So we do have x minus, this one took out x squared, so we do have x minus 1, and then minus x minus 1. Took out negative 1 here. So factor by grouping. So what we found here, so this one is just consider x squared minus 1, and then x minus 1, along with that 4x on the top. So the first part of this one is a quadratic factor. The second factor is a linear, so decompose it. So we do have ax plus b over x squared minus 1, and then the other one, the linear factor, x minus 1, so let's put a d right there. So basically just solve for a, b, and d along with this numerator. Again, follow through the step that we went through, convert that to the same denominator, LCM or LCD, and then take out the terms that with the like term, the like variable. So you can solve for a, b, and d. Again, this part right here, that's already done, x plus 1. So the only thing that you have to decompose is just the rational expression. Okay, so that's it. Thank you for watching the video today. So any questions, any comments, so feel free to put it in right there under the YouTube channel bar. Okay, so, and I'll see you guys next time. Have a great one. Take care.